Hello student, I welcome you to the electronic devices circuit lecture number 5. I want to take a pen. Okay, lecture number 5, in which we will discuss about energy band gap in the semiconductors, in the materials and the insulator. What exactly mean by semiconductor? And if time permits, we will see intrinsic. Intrinsic we have already covered. Then we will go for the extrinsic semiconductor materials. Okay. So before starting of the lecture, if you are not subscribed my channel, so please subscribe the channel. So you will get the whatever the video updates which I have uploaded and the live session which I will be covering in the few days, upcoming days. So if you are not subscribed, please subscribe the channel. Okay. So what I exactly mean by energy levels? That is energy band. So we know that in the every elements, every atom is having one valence band and one conduction band. Okay, these are the nothing but the energy level. So one valence band is there. So valence band is nothing but what? Suppose this is nothing but my center, that is nothing but nucleus, and here are the orbits. The circle is not clear. So suppose this is having one electron over here and one electron is revolving over here. Okay, so at this orbit, last orbit, here the whatever the orbit, if I am having electrons, so that are called as the valence electron. Whatever the orbits are in the last orbit are called as for valence electrons. Okay, valence electrons. So can you tell me what is the valence of silicon? How many valence electrons are there in the silicon? Can you tell me? And what is the valency of germanium? So comment box is open to you. You can answer me in the comment box. I am watching your comments. So please comment on the comment box. I am watching your comments. I will wait for how much? I will give you 5 to 10 seconds for you. Okay, 5 to 10 seconds I will give you. I'm watching your comments. Okay. Okay. I'm not giving you answer right now. At the end, I will give you the answer. Before that, if you have not watched my last lecture, go to the playlist and watch the lecture first, and then you can able to answer. Because okay, correct. You are giving the answers. Okay, we'll see. I will see in the next lecture. I will give you. So, what happen if some bombardment of some photons on this atom is there? So what will happen? This electron will leave. What will happen? This will leave and they will go to the conduction band, and this conduction band will carry this will take part in the conduction. Okay, whatever the electrons are there, because electrons will go in this one, so overall current will flow in this direction. Okay, so in the insulator, the band gap in between means band gap is nothing but the conduction band and the valence band. Whatever the band gap is there, that whatever this band gap is called as band gap. Means difference in between this energy level and this energy level is called as band gap. This difference is, I will drop this session. Just a minute. Okay. So the band gap of this one is near about 5 electron volt, more than 5 electron volt. Okay. Electron volt is the unit of energy. Okay, keep in mind. I will tell you what exactly mean by electron volt. I will tell you over here. If I am not covered over here. Okay, I have covered over here. Also, in the next slide, I will explain what is meant by this one. So this energy, if I am giving the energy to valence electron, still the electron will not jump from this end to this end, because electron will occur or will live in valence band and conduction bond. In between that, it won't leave. Okay, so if the electron will observe the energy, it will try to jump to the conduction band, but its energy is the gap is very high, so it will not go to the conduction band. Okay, it will not go to the conduction band, so it will stop over here. Okay, so conduction will not occur in the insulator, but in the semiconductor, what will happen? The band gap is small as compared to, I will say what exactly band gap in the insulator. So what will happen if some bombardment of photon is there, some electric force is there applied on that one. So what will happen? This electron in the valence band will jump to this band. Jump to. So if the valence in that one is jump to this one, so it will go to the conduction. So this gap, whatever the gap, this energy the electron must have to observe, means electron will gain that energy and it will go on that one. So this is medium level. And in the metal, the conduction band and the valence band are overlap. So whatever the valence electrons are there we are having, that are already in the conduction band at 0 Kelvin also, 0 degree Kelvin also. So conduction will occur in the metal at even at the 0 degree also. Okay. So we'll move on that. So are you getting what I exactly mean by energy levels in the semiconductors, in the insulator? Just a minute. Okay, in the insulator, in the semiconductor and the metal. So in the semiconductor, I will explain once again to you. In the insulator the gap is very high, so the electron, whatever the electron at the last orbit, it will won't go to the conduction band, because if you want to conduct then electron must be in the conduction band, so it will not carry the current. Okay, so in the conduction in the semiconductor the gap is small as compared to this one, so it will the electron will jump from this to conduction band and the current conduction occurs. Likewise in the metals, the conduction band and the valence band are overlap, so already the electrons are in the conduction band, so that's why conduction will happen. Okay, so electron volt is there, that is the unit of energy. Keep in mind energy is there, coulomb is also unit of energy. Okay, charge itself, I can say the charge itself. Okay, so what will happen, electron will be nothing but the W, work done is equal to Q into V. Okay, suppose one electron is having how much charge, 1.6 into 10 raised to minus 19 coulomb charge is there, okay, on one electron. And if that charge is placed across 1 volt, then whatever the energy is called as 1 electron volt. So if electron is having this much energy, if I am multiplying, so I will get 1.6 into 10 raised to minus 19 electron volt. Okay, because I am multiplying this thing, so I will get 1.6 into 10 raised to 19 electron volt itself. Okay, so that is the unit of energy. Okay, so band gap of silicon is germanium is how much, 1.6 into 10 raised zero point 0.6 electron volt, 0.67 electron volt, as compared to band gap of silicon is 1.1 electron volt, and GS band gap is 1.43 volts. So that's why to we are, if you are using the GS material, so it will consume more energy as compared to germanium, as compared to silicon. And silicon is the mid range, this is very small band gap, and it is required some more, and it is also required medium. So as electrons in the valence band of silicon must observe more energy than the valence band of germanium to become a free. What I'm trying to say, this is in this band gap is very less, okay, as compared to this one and this one. So, the electron form this. I will rub this portion once again. Okay, just a minute. I will rub. Yeah. So the electron have to go from this valence band to conduction band. This is the funda. Okay, this is the funda. So if the band gap is less one, so it will require less energy. So in the germanium, the band gap is less. That's why it will consume less energy and it will go from valence band to conduction band. Like this one, in the silicon, it will require large energy and more energy required in the GS. Okay, gallium arsenide. Okay. So we will move towards the next thing, that is nothing but the extrinsic material. So what happened in the intrinsic? Intrinsic is nothing but the pure form. Means this is also silicon. Okay, this is silicon, this is germanium, and this is gallium. But what will happen in the intrinsic material? What will happen in the intrinsic material? The number of electrons are very less, that we can't use of that are not practical use. Okay, practically we can't use. We want, we will add some kind of impurity in that one, and we will either increase the number of electron or either we will increase the number of holes. I will tell you what exactly I mean by holes. Okay, so if we am using a pentavalent impurities, we know that pentavalent are nothing but what, AAP, I have told you, antimony, arsenic, and phosphorus. If I am adding in the my silicon, germanium or GS, I can use for this P. Then what will happen? I will show you in the next slide. So this I have used. Okay, this is nothing but what you can say antimony. Okay, SB I have used over here. So what will happen? This is having five. Pentavalent is nothing but what five electrons in the last orbit. So these four electrons of this first, second, three, and four, they will make a covalent bond with silicon. This first, second, third, and fourth, and one extra electrons are there. Okay, so that's why electrons will get more. Okay, electron will get more. That's why it is called as this overall charge will be n type. Okay, this is the but what will happen in this n type material is there. Getting what I'm trying to show you? Okay, so what I have did is antimony, that is nothing but the Sb, is added to the silicon. So what will happen in this case? So one extra electrons are there, so overall charge will be negative. So that's why nothing but the n-type material is there. So this is called as donor atom. Okay, what will happen? It will donate one electron to the atom. Okay, it will have, and the normally we are using 10,000 to 1 carrier itself means one 1 lakh, sorry, 1 lakh, 1 lakh. What will have, if silicon is 1 lakh, then impurity is 1 added, that is nothing but the 1 atom of antimony is added. Not we are using that if it is we are adding 1,000 and all that. If 1 lakh is there, just 1 carrier we are adding it. Okay, so this is the next bit is nothing but the p type material. Okay, so p type material is what? Suppose if I am adding the trivalent impurity. Trivalent is nothing but the I have used the trick, that is nothing but the Big, that is nothing but the boron, indium, and gallium. If I'm adding that one, so what will happen? It is not having three electrons in the valence. What will happen? So it will form an covalent bonding with 1, 2, and 3 silicon, nearby silicon atom. But here one space is there. So if we want to fill this space, so what is required? One electron is required for this one. So keep in mind, electron is having how much potential? It is negative potential. Okay, negative potential is there. Electron, negative potential. So here, if I want to attract one electron over there, so this potential must be what? Positive. I'm repeating once again. This is the blank space. Blank space. So if I want to attract one electron over here, attract one electron over, so this space must be a positively charged because it will attract the negatively charged particle, that is electron. So the void space is called what? Is called as what? Hole. It is called as what? H-O-L-E. Hole. It is called as hole. Okay, it is not a proton. Keep in mind, it is not a proton. So it will accept one electron, that is called as acceptor impurity. Okay, so what we have seen in this one, we have seen energy gap in the insulator, in the semiconductor, and in the metal. Okay, likewise, we keep in mind this three yeah. And n-type material, we are adding pentavalent impurity like antimony, arsenic, and phosphorus, and it is called as donor atoms. Okay, and in the p-type material the hole is formed because it will attract the negative charged particles. So this space must be a positively charged space, so it will accept the free electrons. Okay, so we will stop over here. So thank you very much for attending the lecture. Paste your comment your doubts in the comment section. If you are not subscribed my channel, please subscribe and like and share this session. Thank you very much for attending.